Hello everyone. Today in this new video we'll be gonna discuss about the theory behind test of significance. It is one of the important topics in statistics, in applied statistics, to give some kind of conclusion, some kind of inference regarding a hypothesis, or in any types of research when we pursue some kind of tests like t test, f test, and there are some other non-parametric tests also. So either the conclusions are showing some kind of significance results or not, this could be achieved through this test of significance concept. Okay, so we are moving forward to our next slide. Now before to know about the test of significance, we have to know about the parameter and statistic. So these are two of the terms that has been used in statistics. The parameters are defined as that for the population. Whenever we get some of the population, they are defined by some of the parameters like mean, standard deviation, proportion, variance. These are some of the parameters for the population, and they are denoted by Greek letters. Like we can say mu is denoted for population mean, sigma is denoted for population standard deviation, sigma square is for variance, like this way. Whereas in other words, the statistic is term for the something that is being calculated from the sample. Okay, whenever the population from the population we draw a sample, an appropriate representative sample from that particular population, then if we calculate some kind of sample mean, sample variance, sample standard deviation, then we can say these are comes under statistic, not statistics. Statistics is a subject and statistic is a something that has been measured from the sample. Now in this slide it has been already been said only statistics such as sample mean, sample standard deviation, sample proportion, etc. So we can see the population parameters are defined by Greek letters mu, sigma, sigma square. Similarly, sample statistic are defined by sample mean is defined by x bar notations. These are some of the notations that has been used for statistic. And in the next line it has been said that statistic are random variable because it varies from sample to sample. On the other hand, parameters are fixed constant. So this is very logical to understand that when a person draw a sample from a particular population, his sample mean we can say it will be somewhat different from the other person that will be drawing the same sample from the same population, but his sample mean will be somewhat difference will come. Okay, so this difference is there in terms of statistics, so they are considered as a random variable. We can say random variable concept we already has been discussed in our distribution video, that random variables are the variables that can take any values. Okay, whereas parameters are fixed constant. The parameters are unknown for a given population. They have to be estimated by the corresponding statistic. So this is very important point in terms of theory of test of significance, because here we are giving conclusion about the population in terms of statistic that has been calculated from that particular population with the help of a sample, and the statistic are used to estimate the value of the population parameters, because in most of the cases the population might be infinite. It might be infinite population, hypothetical population, hard to reach population. So for such kind of population, this is very much important to calculate the representative statistic for that particular population parameter and give a conclusion regarding that particular population. Okay, so moving to the next slide, here the notations that has been used is been given. Here we can see for standard deviation, capital S has been used for statistic, and there is another name that has been in the books also, standard error. So it is the same measure of dispersion like your population parameter sigma, but the term that has been used for statistic is standard error, but it means the same. Standard deviation is for population and standard error is for the sample. Now before going towards the tests, in test of significance, we have to know about the statistical hypothesis also. So hypothesis is an assumption, okay. So the definition goes is like that. Statisticians are called upon to make decision about statistical population on the basis of sample of observations. For example, if we draw a random sample, it may be required to decide whether the population from which the sample has been obtained is a normal population with mean 40 and standard deviation 3. In attempting to reach such decision, it is necessary to make certain assumptions about the characteristics of population. Such an assumption or statement is known as a statistical hypothesis. So in statistical hypothesis, we can simply understand that it's an assumption or a statement about a particular population, okay. And in the previous slides already I have mentioned that populations are defined by some kind of parameters. So here the example also been considered for a certain kind of population. It has been given an assumption that its mean is 40 and standard deviation is 3, okay. So this certain kind of assumption or statement about a population is known as statistical hypothesis, okay. Till now we have been discussing about test of significance, test of hypothesis. So the definition is in 2-3 lines, that the procedure which enable us to decide whether a certain hypothesis is true or not is called test of significance, or in some books it is also there as test of hypothesis, testing of hypothesis, okay. So this procedure, how we have to proceed towards giving a conclusion, towards giving a inference regarding a hypothesis, either it is true or not, this procedure is also only known as test of significance or test of hypothesis. So here also we have two kinds of hypothesis we have to consider. One is null hypothesis, that is hypothesis of no difference. It can be defined as hypothesis of no difference, and it is denoted by H naught. Carrying forward the particular example that has been discussed in statistical hypothesis definition, that the population mean is 40, okay. This is the null hypothesis that has been considered, that H naught mu equals to 40, and against each null hypothesis there will be alternative hypothesis, okay. Three kinds of alternative hypothesis we can consider for test of significance, that is, one is not equals to 40, one is greater than 40, and one is less than 40. But in a particular test we will not be testing all the hypotheses simultaneously, but testing any one of them. Against a null there will be only one alternative hypothesis. So any hypothesis which differ from null hypothesis is known as alternative hypothesis. The null hypothesis is tested against an alternative hypothesis. Now coming to the next slide, the sample is then analyzed to decide whether to reject or accept the null hypothesis. For this purpose, we have to choose a test statistic and find its sampling distribution. So it is assumed that null hypothesis is true. The observed value of the statistic in the sample will be different from the expected value due to sampling fluctuation. If the difference between them is large, we reject the null hypothesis, otherwise accept. So going towards all these kinds of tests, we require a test statistic, okay. And test statistics should follow some kind of distribution, sampling distribution. So here basically there are some kind of test statistic that will be considered in this particular video, say Z test, T test, chi-square test. So for each test there is a test statistic, okay. So in coming slides we'll be knowing about this particular test statistic, okay, when how to accept or reject a null hypothesis. So if null hypothesis is not rejected, then the difference between the observed and expected value is considered solely due to sampling fluctuation, because the main observation in terms of test of significance is about the difference, the significance difference between the observed value and the expected value, okay. And the observed value is always calculated from the sample, and the expected value is the expected value that has been considered in this particular example is 40, okay. So either it is equals to 40 or not equals to 40, that will be determined with the help of a test statistic. So the decision about rejection or acceptance of a null hypothesis is based on probability consideration. So we'll be taking help of the probability distribution curve as well as probability theory while giving conclusion regarding the decision of acceptance or rejection of a null hypothesis. We calculate the probability of obtaining a difference equal to or greater than the observed difference. If this probability is found to be small, say less than 0.05, then the conclusion is that the observed difference is significant at 5% level of significance and the hypothesis is rejected. So if the probability is higher than 0.05, then the conclusion is that the observed difference is not significant at 5% level of significance and the hypothesis is not rejected. Okay, so this 0.05 is the level of significance, is the significance level, and where we can test either the hypothesis that we have considered, either it is the test statistic value is either falling in the rejection region or the acceptance region. It could be 0.01 also, it could be 0.10 also. It depends upon the particular person who is doing this particular testing of hypothesis. So it is not like that always it will be like 5% level of significance only. It could be 1% also, it could be 10% also, 20% also, like this way. So the theory behind the acceptance or rejection is lying between in here, that whenever this observed difference becomes greater than some kind, the probability becomes greater than 0.05, then it falls under the acceptance region. Whenever it becomes smaller than 0.05, it falls under the rejection region. Okay, so in test of significance there are two types of test. We can go for two-tailed test also, and we can go for one-tailed test also. One-tailed test is further divided into right tail as well as left tail. This will depends on the alternative hypothesis of the problem. Okay, so we cannot perform all the test for a particular single null hypothesis. We have to consider only one tail, or it could be two tail. Okay, so this is the difference that has been talking in the previous slides, that what is the difference between the observed value and the expected value. Here we can see this observed value is our x bar, that is been calculated from the x bar is nothing but the statistic sample mean, and the mu is the expected value, that is the that is for the population parameter. So their difference lies where the probability has been considered. If the difference is lying between minus 1.96 sigma by root n and plus 1.96 sigma by root n, this probability is given by 95. Okay, 95% means. And if this value exceeds 1.96, then it falls under the rejection part, that is 0.05. Okay, because we all know total probability distribution curve is 1. So 95%, if we consider 5% level of significance, then 95% is our acceptance region, 5% is our rejection region. But when we'll be going to reject the null hypothesis, when this observed difference becomes greater than the 1.96, okay, 1.96 sigma by root n. Sigma is also having some kind of value, root n is the sample size, it will also have some kind of value. So in this particular value, if the observed difference exceeds this particular value, then it falls under the rejection region and its probability is 0.05. We have to reject the null hypothesis. But if the observed difference, the difference between the observed and expected value lies within the this range, minus 1.96 sigma by root n to plus 1.96 sigma by root n, then it falls under the acceptance region, and which probability 0.95, that is 95%. Okay, for say for 95% probability we are accepting the null hypothesis, and for 5% probability we are rejecting the null hypothesis. And this comes from the Z. Z is nothing but a standard normal variate, and it's a Z test. So for all the large sample tests that been performed in statistic, large sample in the sense that any sample size which is greater than 30 should use Z statistic to give a conclusion regarding a particular population. Okay, so there are other tests also for less than 30. We'll be observing them in the coming slides. So that was for 5%, and this is for 1% confidence limit, that is minus 2.58. So for each level of significance there are certain kind of Z values. Say for 5% Z value is 1.96, for 1% Z value is 2.58, like this way. Okay, and this is some kind of graphical representation of how to where our acceptance region and rejection region is lying. So you can see that in two-tailed test our rejection region lies in both sides of the probability distribution curve, whereas in one-tailed test, in right-tailed test, our rejection region lies in the right-hand side, whereas in left-tailed test, our rejection region lies the left-hand side. So I was talking about this particular Z. This is the first test statistic we have been discussing in this particular video. That is the Z test, and this is valid for large sample. Large sample in the sense that sample size should be greater than 30. So is the formula is simple. It is simply the observed value minus expected value divided by standard error, And now standard error we all know that is can be calculated from the sample, and it proposes same like standard deviation. Okay, and observed value is x bar, that will be calculated from the sample, and expected value could be given or could not be given. Okay, so putting all these values in the z test statistic will be getting one calculated z value. Okay, then we have to compare with a tabulated z value for the rejection or acceptance criteria. So here we can see for two-tailed test 5% level of significance, modulus of z is 1.96, and for 1% level of significance the value of modulus of z is 2.58. Now alpha being the level of significance is the maximum probability with which the null hypothesis is rejected. That already I have said that it could be 5% maximum probability we are rejecting the null hypothesis, it could be 1%, it could be 10%, it will depend upon the person who is doing this test. And here the critical reason is also defined as the rejection reason is a set of values of the test statistic for which the null hypothesis is rejected. So here some other graphical representation of two-tailed test. Here we can see minus 1.96 to plus 1.96 is the acceptance reason, and whereas 0.05 here we can see we have since 0.05 has been further divided into two parts, alpha by 2 and alpha by 2, that is 0.025 and 0.025. So this is also one of the pictorial representation only, when to reject and when to accept the null hypothesis. So total probability distribution curve is 1, and 1 minus alpha is the acceptance reason and alpha is the rejection reason. And this is goes for right tail test. Right tail test, you can see the critical value for right tail test is 1.64. and for left tail test is minus 1.64. Okay, so these are some of the steps that should be followed while to perform the hypothesis testing. That is, first we have to set up a null hypothesis and alternate hypothesis. Second, we have to appropriately select the test statistic. Either for large sample we are gonna test it, either for small sample, that will depend upon the particular research. But the test statistic is very important. Either it is for small sample or large sample. Then in the third step we have to also decide the level of significance. Either we are considering 5%, 1%, 10% like this way. And then we, depending upon the alternative hypothesis, our critical reason, that is the rejection reason, either it is lying in the right hand side, either it is lying in the left hand side, or it is lying in the both side. And lastly we have to calculate the test statistic value on the basis of sample data. Okay, and the conclusion lies in like this way: if the calculated test statistic value is greater than the tabulated test statistic value, we have to reject the null hypothesis, and otherwise we have